In this video, we are looking at using lenses. You might recognise this lens from the previous video. It's a concave lens, and we said that an image is formed at the focal point F for very distant objects because the rays are almost parallel. But what if the object is nearer to the lens? The position and type of image formed depends on two things: the focal length of the lens, F, and the distance of the object from the lens. The focal length is the distance between the lens and its focal point. If you know these, you can draw a ray diagram to find the position and type of image. There are three rays you must draw to do this. Here, there is an object on the left of the lens which is an arrow. The first ray is drawn parallel to the principal axis from a point on the object, the top of the arrow in this case, to the lens. After reaching the lens, it is refracted towards the focal point on the other side of the lens. The next ray runs straight through the centre of the lens without any refraction. It is just a single straight line. It should cross the other ray on the other side of the lens. The final ray should go from the same point on the object through the focal point on the same side of the lens as the object until it reaches the lens. After reaching the lens, it is refracted and is now drawn parallel to the principal axis. It should now cross at the same point the other two rays did. Notice how the image is real and the image is inverted. A camera uses a convex lens in this way. Based on what we know, where do you think the camera film must be in order to capture a clear image of a very distant object? And can you explain why? Where do you think the camera film must be moved to in order to capture a clear image of a closer object? i.e., the closer the object, the greater the distance between the lens and the film. So how do you draw ray diagrams if the object is between the focal point and the lens? For this, you must draw two rays. The first ray leaves a point on the object, the top of the arrow, and then moves parallel to the principal axis until it reaches the lens. The ray then refracts and moves through the focal point on the opposite side of the lens. The second ray leaves the top of the arrow and passes straight through the centre of the lens without refracting. Notice how the rays are now diverging or moving away from each other. Now trace the rays back, and where they meet, the virtual image is formed. And finally, what about a concave lens? The image formed by a concave lens is always upright, virtual, and smaller than the object. How would you draw this diagram? There's no quiz this time. The best thing to do is to practice drawing ray diagrams for lenses. Try drawing ray diagrams for a converging lens with a focal length of 1.5 cm for a 2 cm tall object placed at the following distance from the lens: 5 cm, 2 cm, and 1 cm. Also try the exam question in the description. Good luck!